Vi hör inget ljud.
Nej.
I don't hear anything.
Mark Musin is an international well-known expert in medical knowledge. He comes from Stanford University Medical School. I'm Yusheng from People's Hospital, Peking University. Recently, we have cooperated with a domestic HIT company to realize our theoretical model and began to make further study in knowledge discovery and the clinical manifestations standard. Our cooperative research work began in 2014. After a long period of research, we found that there are a lot of disease ontologies already, but it's rare to see the popular use in clinical setting. We think that there are two key constraints. One is the lack of medical knowledge rules. It limited us to develop high-quality disease ontologies. 30 years ago, the medical expert system had encountered the problem. Two problems is different disease ontologies are not compatible with each other. This leads to incompatibility of clinical data based on different ontologies. In recent years, people have been very interested in knowledge graphics. Generally, natural language processing can only obtain some simple rules from the real data and cannot understand the relationship between the rules through ontology-based deep learning. It can understand the accurate meaning of clinical data and the meaning of the self-learning result. Man-machine cooperation can maintain knowledge base. Human can only understand our own knowledge system, how to control the goal of this knowledge tree. We can have to use the man-knowledge ontology to limit this goal, and the man-machine interaction can control the self-learning steps and to understand and confirm the new knowledges. Knowledge base supports structured data capture. Usually, CDSS is mainly used for clinical decision support, including diagnosis decision and the treatment plan decision. The CDSS gives suggestions for clinicians to choice. We hope to change this situation and to support the structured data capture. Later, we will further explain by knowledge model. The medical knowledge model is from CASNet in 1982. People really pay attention and study it further. I think that it is very important for medical AI because few people really understand what medical knowledge is. We convert the CASNet model into the following diagram, which is clearer and easier to understand. In the following diagram, there are three layers: clinical manifestation layer, diagnosis layer, and the treatment layer. The elements in different layers are mapping each other. In the clinic, doctors collect the patient's findings and give a hypothetical diagnosis. This hypothetical diagnosis will map one group of treatments. Medical theory can support doctor analysis the patient condition, but cannot support them to derive the conclusion directly because the knowledge tree of the medical theory and discontinuous, which is different from mathematics. Therefore, the main feature of the medical knowledge is probabilistic. For more detailed diagram in doctor's brain, the diagnosis elements are more detailed than ICD coding and the generally clinician diagnosis. Clinical diagnosis, which keep one diagnosis element, map one group of treatment. This is the reason why we often see that doctor can quickly write out a prescription after collecting clinical findings. Doctors' indecision comes from one to multiple choice between the diagnosis and the treatment layer. At present, it's very difficult to develop a high-quality CDSS to compare with doctors' diagnosis and the treatment decision. Therefore, we change our mind and use the knowledge base to support doctor to quickly in the EHR content and support structured data capture. And furthermore, we found the knowledge base through structured data by machine learning. Structured data capture. Many scholars are working hard to explore ways to obtain high-quality structured data. The Neurological Institute of Cleveland Clinical made a lot of medical record forms and asked doctors, nurses, patients to fill in the forms which spend a lot of time but can obtain high-quality structured data. This is not feasible in China because Chinese doctors are very busy and cannot get help from nurses. Many academic organizations and institutions do a lot of related work, for example, HR7 CEA, FAIR, and so on. EHR templates are very popular for inpatient in China. The SMART template was made for every disease and is called the public template. The doctors will make their own private template based on the public template. When the doctor inputs a patient record, they will code the template and select the right structured findings terminology from multiple choices. If these multiple choices do not meet the doctor's requirement, doctor will re-edit the content in EHR. This EHR keeps the structured data and the free text and is called semi-structured data. Everyone knows that this structured data has ambiguity and its free text is difficult to understand for machine. This is the reason that we are going to develop the ontology-based clinical knowledge graph to help a doctor input structured data in EHR and get high-quality structured data to support the machine learning and the big data study. In this slide, we convert medical knowledge model into this diagram. It's clear to show the ontology structure of every knowledge layer. The yellow part shows the clinical findings structure. The blue part shows the clinical diagnosis structure. The orange part shows the treatment structure. All of them is supported by terminology system. Treatments have not ambiguity. Diagnosis is coded by ICD-10 in oncology structure, and the most difficult part is the clinical findings. The symptom ontology was studied by different scholars. As shown above, the symptom ontology was developed as part of a Gemini project starting in 2005 at Tiger, or continues on the project at the Institute of Gemini Science at the University of Maryland. The virtual science ontology was developed by Barry Smith at Buffalo University in 2011. It is a useful term to standard the clinical findings and avoid ambiguity. Construction of EHR templates based on medical knowledge graphics. Just now, we already analyzed the medical knowledge model and get the following conclusion. 1. The medical knowledge is a lack of rules which cannot support doctor to make clinical decisions directly. 2. Medical knowledge graphics is easy to use for EHR templates, not for clinical diagnosis and treatment decision. 3. Deep learning can optimize the knowledge tree structure and the weight coefficients. We hope to develop the inheritable and the portable EHR templates to meet the need of different medical levels. For example, for different doctors and the different hospitals who need different detailed templates, even if the same doctor faces different patients and needs different templates. We can build high quality templates for doctor to use, but how to keep it inheritable and portable is a big challenge. The portable template means that it can be transplanted from one hospital to another hospital, which need more standard for clinical findings, diagnosis, and treatments. Medical knowledge graphics recognized by most clinical doctors. This slide shows the challenges of inheritable templates. We need to keep compatibility between the need between the new and the old knowledges in order to keep the data consistent. We can imitate the way that the human being learn new knowledge, depend on the old knowledge, and keep them compatible with each other. This is my presentation. We have only experimented with part of our idea, and there are still many problems that need to be solved in practice. Hope to obtain your opinions and suggestions. Thanks.